Hello, this is Jack Jackson. In this video, we're going to be talking about programming a hypergeometric program for a TI-84 calculator. So the TI-Inspire and the TI-84 both have built-in PDF and CDF functions for several important types of distributions, including geometric and binomial, which we've looked at so far, and Poisson, which we're going to look at a little bit later, but they do not have such built-in functions for the hypergeometric distribution. And the hypergeometric distribution is an important distribution, so it'd be nice if we had such a thing. But recall that the hypergeometric PDF is actually just made up of three combinations or binomial coefficients, and binomial coefficients or combinations are actually built into the calculator. Now, unlike the TI-Inspire, the TI-84 does not allow us to program new functions, but it does allow us to write programs. And so we will program in this video the TI-84 with a hypergeometric CDF program, which will serve in a similar way to the HGO CDF function we programmed into the TI-Inspire. And note that we don't really need a separate hypergeometric PDF program because we could just do a hypergeometric CDF, which is going to do the probability that x is between two numbers. Just make sure those two numbers, L and U, are the same number, and then we get the probability of that particular number. So we're going to get started here, and I'm actually going to be putting this program in from scratch, one line at a time. So here's what you need to do. You need to get your TI-84 if you're using this calculator. TI-83 will work the same way. So get your calculator out, have it ready to go, and follow along with me. And as I type in things, you type in the same things in your calculator. And if you need to, pause and catch up with me if I get going too fast. But along the way, I'm going to be showing you which buttons to push, and you'll be able to see my mouse moving around. And then you're also going to, I'll try to explain what the program is doing as we go along. Now I'm going to name this HGEO CDF. Now I actually already have this program in my calculator, so I'm going to do it again with the name HGEO. Actually, you can name it anything you want, up to a certain number of characters here. Okay, so let's go ahead and actually get started with this. Okay, so here is the TI-84. Okay, and let's take a look at this program. So first of all, when you hit program, you're going to see a list of programs. Now these are the four programs here that are going to be used in this course, in this section of the course. There's going to be an HGO CDF, which is what this video is about, and then later on there will be 3 videos that will show you how to do the inverse binomial, inverse geometric, and inverse hypergeometric. So this is to do hypergeometric probabilities, is the one this one is about. Now you may have no programs here at the beginning. You may have some from another course or something, so someone has put these in, either yourself or someone else. But you can either go to execute, or you can edit existing program, or create a new program. And we're going to start with create a new program. Now before I do that again, let me review here. If you hit the program button, this is what you see at this point, but this is going to change in just a minute. So we go to new and we say create new. Now it's in alpha lock, so when it's in alpha, you're going to see the green letters above the keys are what you're going to be using. So we can name this whatever we want. I'd rather you name it, I want to name it HGEO. Now these letters are in just alphabetical order. G-E-O. And then I would say CDF is what I would do. But I already have one named that, so I'm just going to stop right there and hit enter. Now notice at this point you're in the program. It'll say program HGO or HGEO CDF at the top for a hypergeometric CDF program. Now at this point we're in the programming editor. So if we hit program, notice that we get something different than what we got before. You get control statements here, if, then, else, for, while, repeat, end, and there's some more below that. or input-output statements by pressing the right arrow, things like input, prompt, display, and some others. So mostly some of the commands we're going to be needing are going to come from there. In particular, we're going to be using the display and prompt commands quite a bit. And we're also going to be using the for and the end commands. So those are the main ones we're going to need in this particular one. We're going to start with the display command. So we go to here, and you have two choices. You can either down arrow to the 3, display, and hit enter, or you can actually just hit the number 3 at that point. So now the first thing I'm going to do is I'm going to put in, let's see, I'm going to put it in alpha lock because I'm going to be programming in several different things here that are all characters, text. So I'm going to start with a quote. Quote is the green quotation mark, which is above the plus key, so I hit the plus key. So quote, and I'm going to type in total population size. Okay, so that's, let's see, here we go, TOTAL, space is the 0 key, space, population, POPULATION, Now, on this calculator, you can see that's as many characters as will fit on one line. Some of you have the brand new TI-84 color edition that has a higher resolution screen, and you may want to keep going in the same line. But I'm going to click enter, and notice we click enter at the end of each line, and each line of text starts automatically with this colon. That's not something you have to type. It comes up automatically. Now, hopefully you're following along with me and are up this far. If I get too far ahead of you, just press pause and catch up with me. Okay, now we're going to display. So this is going to, when this program runs, this is going to actually type in total population as text across the screen. Whatever's between the quotes will actually show up on the screen. So there are three basic parts of this program, or pretty much any program. There's the input phase where we input, we react with the user and get the user to input information. Then there's the basic guts of the program that actually does the computation. And then at the end, then there's the output portion where we output our results back to the user. So we're in the input portion of the program. So I'm going to go to program again, go over to I/O. Displays number 3. This time I'm just going to push the 3 key, and that takes me to display. I'm going to put an alpha lock again, which is second alpha, quote, total population, and I want to put size, S-I-Z-E. Now, if you want to phrase this differently, that's your prerogative. It actually works whether or not you display this on the screen, but this helps the user know what to put in. Now we come to an important thing. We go to Program, right arrow to Input Output, and choose number 2, Prompt. And then I'm going to prompt, and I need a letter for this. I'm going to use, well, we normally would use capital N for this, for the population size, for hypergeometric. Unfortunately, we also use the lowercase n for sample size, and the TI-84 is not going to have a different variable between lower and uppercase n. So I'm going to reserve n for the sample size, and I need a new letter here, so I'm just going to use S this time. You can pick any letter besides one of the other letters we're going to be using, but I'm going to do prompt S. Now, when this actually runs the program, it's going to come to this prompt S stop, and it's going to stop the program. And you're going to see total population size S question mark. And next to the question mark, the user is going to put in the S value, which in this case is our capital N value, the population size. And type in that number, enter, and it will proceed with the rest of the program. So next we're going to put in another input-output statement, display again, and we're going to put an alpha lock and then type in number of successes in population. And again, if you want to just say successes in population and don't put number, that's your prerogative. You can put what you want. This is the way I'm going to do it. NUMBER space of space. Well, I can't get successes in on the same line, so I'm not on this calculator. So I'm going to quote and enter that line, start a new line for another display, another alpha lock, another quote, number of, now I want successes, S-U-C-C-E-S-S-E-S in. Alright, can't get the rest of it in, so I'm going to do quote, enter, and then another display, quote, sample. M-P-L-E quote. Now, if you wanted to just say something like sample successes or something like that, a little bit simpler, you can, but I think this is pretty good, at least one way to do it. So I'm going to do input output again by hitting program, right arrow. This time I'm going to another prompt, and I want to prompt it for that, the number of successes as sample. What letter do we usually use for that? Well, we use M, capital M. So we're going to use that again here as normal, the normal letter. Next, we're going to have it input the sample size. So we're going to go to program, display again, alpha lock, quote, sample size. S-A-M-P-L-E. I think I can get all this in one line. Size, we're at my S-I-Z-E. Takes a little getting used to the letters being in alphabetical order instead of like a computer keyboard layout. Program, right arrow, number 2, prompt. And the sample size is what we're going to use is lowercase n, but it'll just be alpha n on this one. Okay, so now the person has put in that. Now, in this case, they also need to put in how many successes they want. And actually, we're going to do a probability between a lower and an upper one inclusive, like the TI Inspire does on the CDF functions. So let's tell it that's what we want. So we go to Program, I/O, Display, and we can go with something like successes. Oops. In let's see. Sample. Okay, maybe a new line for the next for sample. Okay. Okay, hope I get all my spelling right here. Successes in sample, and we'll say lower. So we might go lower limit or just lower if we want to, whichever you want to do. Lower, how about lower limit? Okay, and then we're going to prompt it for L. Okay, so that gives us a lower limit, and now we're going to prompt it. They're going to tell it to give us the upper limit. So we're going to go there. Display again. quote upper U P P E R, and if you just want to say upper, that's fine, but if you could say upper limit if you wanted to. That'll all fit on one line anyway. That's nice. Then go over to prompt upper, which is going to be U. All right, so we're done with the first phase of the program, which is getting the stuff in there, right? Getting the inputs in. Now we get to the guts of the program, which is really pretty small on this one. We're going to initialize. P is going to be our answer, but we want to make sure it starts out with 0 in P. So we're going to start by going 0, store. Now the store key, see my mouse moving around here? See the on key, go up 1, the STO key, that's going to give you the arrow. And so we're going to store that as, let's see, we're going to store that as P. So alpha P. Okay, so go ahead and store that as P. Okay. Okay. Now, what we're going to do now is we're going to run what's called a for loop. So let me start by doing it this way. I'm going to hit program and choose number 4, which is for loop. 4 is 4. That's kind of interesting. And we're going to introduce an index variable, which it's going to be k here. Alpha k, comma, alpha u, comma, alpha, L and then u. Alpha L, comma, alpha u. Okay, and I'm going to actually just put a blank space there for right now. I'm going to come back and fill it in. Then I'm going to put another thing that says program. I'm going to put program control number 7, which is n. Now, what happens with this for loop is it starts out with k starts out as L. Then it's going to do whatever commands we put here in the in between, and then it's going to go to end. Then it's going to add 1 to k, and now k is going to be L plus 1. It's going to go back and it's going to re-execute these commands. Then it's going to add 1 to that, and it's going to be k is going to be L plus 2, and L plus 3, and L plus 4. Finally, it gets up to u. When it ends this last time for u, k will be u plus 1, and it sees that that's bigger than u. Then it does not execute the loop again. It continues on with the program. Okay, so let's take a look at what that. There's really only one command that we're going to put in here, and basically what we're going to do is we're going to find the probability that x equals whatever k is, and we're going to add that to our p, and that's going to give us our running total, our cumulative sum running total for the probability. So we're going to work this out first for L, and then it's going to add it to 0, and that's going to be P. And it's going to store it back in P, so that whenever we go back the next time, we're starting with a higher value of P, and then it adds on the PDF at k equals L plus 1, adds that back on, and so forth. So all we really need to do here is to do a pretty simple command, but we have a formula for the PDF of a particular k value. And here it is. Open parentheses for the numerator. And then we have a probability here, which is a combination. It is the number of successes total, which is M. And then we choose. Now remember, choose this or combination is under math. And we go over to probability. And we choose number 3, NCR. And from those NCR, we're going to choose K of them. So that's the number of ways of choosing our K successes from the total of M successes in the population. Now we're going to multiply that times parentheses, another combination that's going to count the way of doing our failures. Now first of all, let's see, we need another parentheses. Now let's count our failures in the
So we have our total sample size, which is capital N normally, but we used the letter S in this program because we can't use two N's. So total population size minus the number of successes in the population gives you the total number of failures in the population. From there, we're going to do another NCR, and we're going to do how many failures are in our set. Well, we're choosing a total of total sample size of N, and K of them are successes, so that leaves N minus K failures, and we want to choose those from the S minus N. So the N minus K is the failures in our sample, and the S minus M is the failures in our whole population. Now, we close this N minus K. Now we're going to close one more. That goes to close this one that closed the combination, and we're going to close one more that closes this one at the beginning, so that closes the whole numerator. Divide. Open the denominator. It's also a combination. It's the total ways of taking everything and choosing a sample. So everything was S. Normally it's capital N. But we're going to use S in this program. And from that we're going to choose NCR N of them. So that's alpha N. Close parentheses. All right, that is the PDF of that particular K. So we want to take that and add it to alpha P and store the answer back in alpha P. And then end is after that. So now look what's happening. It'll run this once. It starts with P as 0. It'll run this once and K is L. So it'll find the probability that that X actually equals L. It'll add it to 0, and now P is just the probability of L. Then it'll go to L plus 1. Do it again, takes that and adds it to the probability P, so now it puts it back in P. So now P is the probability that K is L or L plus 1, those two PDFs added together, and so on. It adds all these up. So now at this point, P is our probability we're looking for. So now all we have to do is display this to our user. So we're going to hit Program, go over to Display again, and I'm going to put something there that tells us what this is giving us. So I'm going to do alpha, quote, alpha P, parentheses, left parentheses, of alpha L less than or equal to. Now to get less than or equal to, we go to test. So second math, we can get our symbols for our less than, greater than, and all that. So number 6 here is a less than or equal to, well, X. The easiest way to get X is just to push this button right here by the green button next to it. And then less than or equal to again. Second math, test. Let's not hit second math. Let's try again. There we go. 6. And upper, alpha U. Now the user will have just put in U and L, so they'll remember what those are. Close, and they'll probably still be actually displayed on the screen. Close that, and then alpha quote. And so this will actually print, and enter at the end of the line. So that will actually print that symbols, P of L less than or equal to X less than or equal to U, parentheses, those letters, not their values, but their letters. Okay, and now we can actually have it display P. Now at this point you have a couple of options. Well, let me go ahead and do this. I'm going to say program over here, display alpha P, and it's just going to display the value of P, and it will be a decimal approximation. Now here's something you can do if you want to do this. You can do one extra line if you want. This last line is optional, but you can also display the P and then go to math, change to fraction, like that, and it will try to, the second time, or if you did that the line before, the one that has changed to fraction will try to put it into a fraction form. So if this has a fraction that's sort of a nice fraction, you know, small enough denominator in reduced form, then this will tell us the exact value in a fraction form. But really, most of the time, we're not going to need that. We're going to want an exact value. But, you know, it might be useful to have this. So oftentimes when you run it
it won't be able to change it to a fraction. You'll just get the same decimal answer twice. But that's okay. So I'm going to go ahead and put that in there, and I think it might be useful. So now when we quit, we just do second quit. You don't have to worry about saving it or anything. Now it's there. And so the program we just wrote was number 1, HGO. Okay, I already have it also in there. I've already put it in there earlier as HGO CDF, so mine's sort of showing up twice. So if we run the one we just did, you hit enter, it comes up, then you hit enter one more time, it runs it. And so let's do an example here. Okay, so let's suppose we have 23 balls. Let me do this. Okay. Okay. So here we're going to do this problem. There are 23 balls in an urn. 15 of them are red. We choose 6 of them without replacement and let x be the number of red balls. We want to know the probability that x is between 3 and 6 inclusive. So we run this program. The total population size is the big N, which is 23. The number of successes in the sample is 15. The sample size is 6. The lower limit is 3. The upper limit is 6. And we get this number. If we did it right, it'll match the number I have here on the slide, which it does. So that's how you run the program. If you wanted to take the same one, for example, I can hit enter, it'll execute the last thing. So I do the same one, do 23, 15, and 6, and say if I wanted to do just the probability that was 3 only, then I would just go from 3 to 3. If I want to do the probability that it is greater than 5, so with the same one, 23, 15, 6, greater than 5. Well, that means it starts at 6 and it goes up to whatever the sample size, which is just 6. That's all there is to it. See, that one gave us a nice fraction. And there it is as decimal. Or what if we say greater than 3? Okay, so greater than 3. 23, 15, 6. Greater than 3 would be from 4 up to the top, and the top is the sample size, which is 6. And so forth. And we could answer all kinds of probability questions in that way. So now hopefully you've been following along with me. You got this in, you were able to get it to work out, and now we can use this to find probabilities from a hypergeometric distribution just as easily as we can use the probabilities to find, you know, the binomial distribution, for example, or the geometric now. So it's very important that you get this program in, you get it running, and that makes a lot of the problems that we're getting ready to do and the rest of the thing actually fairly easy to work out. You just got to sort of identify that it's hypergeometric. You have to identify the n, m, and the n, which are the 3 numbers we put in that order, and then you give it an upper lower limit, and it will find the probability between those two lower and upper limits inclusive. So really all you have to do is just identify those numbers, plug them in the calculator, and it will tell you the answer, and then you can interpret your answer. So it actually makes a lot of these problems really pretty easy to do, but you got to have your program in there first. So be sure that you get that in really well before you go on any further.